Hello friends, in this video we are going to discuss DFT IDFT method based convolution problem. So we have already seen graphical method based and matrix method based convolution problems. In this video, we are going to discuss DFT and IDFT method based convolution problem. Okay, so in your exam maybe you will get questions directly solve the convolution using DFT and IDFT method. Okay, so might be you will get this question for 8 marks. Okay, this problem is very easy. In order to solve the convolution problem based on DFT and IDFT method, you have to know how to solve DFT and IDFT. Then only you can use this method to solve convolution problem. Okay, let x1 of n and x2 of n are two finite sequences of length n1 and n2 respectively. What is this finite sequence? You know very well what is finite and infinite, right? If the sequence, if the, for example, if the x of n sequence lies between any finite value, for example, it lies between 0 to 7, we call such type of sequence as a finite sequence. So, if the values varies between 0 to infinity, such type of sequence we call as infinite sequence. So here the x1 of n and x2 of n sequences are finite. Okay, so it has a finite length n1 and n2. Okay, so in order to solve convolution using DFT and IDFT method, we have to follow these steps. Okay, so first we have to calculate endpoint, because might be we will get the sequences in different size or different length. Okay, then we have to calculate one sequence length, which means using this condition maximum of n1 comma 8. For example, the first sequence length is 4, the second sequence length is 8, means the maximum of 4 comma 8 is 8. Then we have to calculate DFT and IDFT for the endpoint 8 point. Okay, so we have to calculate DFT for the 8 point and also IDFT for 8 point. Second step, so we have to determine the DFT of x1 of n. So usually we will represent the DFT x1 of k, right? So again we have to find out the DFT of x2 of n, that is x2 of k. So finally we have to find out the convolution of two sequences, that is DFT of x1 of k and x2 of k. It is in frequency domain, right? x1 of n and x2, it is a discrete time sequences, right? So we can easily, if we are converting in the frequency domain, x1 of k and x2 of k are in frequency domain sequences, right? So we can easily multiply these two sequences. We will get y of k, right? So thereafter the last step is, so in order to find out y of n, our main motto is we have to find out the convolution of x1 of n and x2 of n, not determining the y of k, right? So then we have to find out the IDFT. IDFT means what? Inverse discrete Fourier transform of y of k. So we have to apply the equation of IDFT, then we have to find out the value of y of n. It is the convolution of x1 of n and x2 of n. So we will solve one problem, okay? Then we will understand the DFT and IDFT method solving the convolution, okay? So this is the problem: two finite duration sequences. Here they have given the n value varies between 0 to 3. So the capital N is 4 point, right? So the small n varies between 0 to n minus 1, alright? 0 to n, capital N minus 1. So here n is 4. 4 minus 1 means 3. So n lies between 0 to 3. So n value varies between 0, 1, 2, 3, right? Similarly, h of n. h of n, the function of h of n is 2 to the power of n. Here the small n varies between 0 to 3, right? Here they have not given the x of n and h of n sequences. They have not given the direct value of values, right, or sequences. So they have given the x of n and h of n as a function, right? They have given as a function. In your exam, in order to confuse you, right? So they will give the problem like this. They won't give the values, right? They won't give the sequences. So you have to find out the values by applying the value of n 0, 1, 2, 3 in the given function. Thereafter, we have to perform the convolution of x of n and h of n using these steps. We know already these steps. I won't repeat again here. Okay. First, we have to find out the x of k and h of k. Then we have to multiply these two sequences. Then again we have to find out the inverse discrete Fourier transform of y of k in order to determine y of n. This is the convolution of x of n and h of n. Right. So here first we have to find out the sequence by applying the value of n. N value varies between 0, 1, 2, 3. First we have to apply 0, right? Then we have to find out the value, right? Sign of 0 means 0 because n value is 0. N value is 0. So we have to substitute the 0 in this function. So we have to find out the value of x of 0. Sign of 0 means 0. Then again we have to substitute the value of n as 1. Then by using calculator find out the value of sine of pi by 2. The sine of pi by 2 value is 1. Again we have to apply 2, n value 2. Then so sine 180 is 0. You know very well, right? Sine of 3 pi by 2 value is minus 1. Similarly, we have to substitute for in order to determine the h of n sequence. So we have to substitute the value of n as 0, 1, 2, 3. You know very well. So 2 to the power of 0, right? Substitute n value as a 0. 2 to the power of 0 is 1, right? So 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3, the n value 3. 2 to the power of 3 is 8. These are the sequences, right, for x of n and h of n. Thereafter you have to find out the x of k for the x of n sequences, right? So using a matrix method, I have determined the values of x of k for x of n. Okay, so by using x of n, I am going to determine the x of k using matrix method DFT, right? This is a matrix method solving the DFT using matrix method. Okay, so you know very well these are the twiddle factors. This is k, this is k, this is n. Okay, so just I will teach you only one row. Okay, wn to the power of kn, right? So here n value is 4, n point is 4. Here kn and k k value and n value is 0. You know very well what is this equation? E to the power of minus j 2 pi, right, divided by 4 kn, right? Here the kn value is 0, right? So e to the power of j0, how will you represent the exponential equation? What is that? Cos theta. This is, you can take this one as a, this is j, okay? This one, this as a theta, right? So cos theta minus j sin theta, right? Sin theta. Here the theta value is 0, right? So cos 0 value is 1, right? Cos 0, sin 0 value is 0. So I can substitute this value is 1. For this row, I can substitute the value 1, right? Again for this column, I can substitute the value 1, right? Then you have to apply this procedure in order to determine the Tidal factors of others. Okay, by using periodicity property, right? I have already taught this thing. Okay, so just see my previous video. Okay, so by using periodicity, you can easily find out other Twiddle factors. Once if you are determining this row, you can easily determine the Twiddle factor of others. Okay. So once if you are determining the Twiddle factors, okay, this is Twiddle factor. This is the value of x of n. See here. So 0, 1, 0, minus 1. 0, see here, 0, 1, 0, minus 1. So just you, once if you are determining the 12 factors, just multiply these two matrices. After multiplying these two matrices, so you will get result 0 minus j2, 0, j2. Just you have to multiply this row with this column. Just I will solve this row and this column. Okay. So 1 into 0, 0, right, plus 1 into 1, 1, plus 1 into 0, 0, plus 1 into minus 1, minus 1, right? So minus 1 plus 1 is, again it is 0. So in this way you have to solve other three rows. You have to multiply this second row with this first column. You will get this result. Again you have to multiply this third row with this column. You will get x of 3 value, right? Or x of x3 of k, or whatever it is. Okay, this row and this column. Finally you will get x of k value. You have determined the DFT of x of n. Similarly, you have to find out the DFT of x of k, DFT of h of k. You have determined the DFT of x of n. You have to determine now DFT of h of n. Okay, then apply the same procedure. You will get the answer. See here the same matrix. Here the matrix, the total factor matrix does not change. Okay, only this value, this is the h of k value. Okay, just you have to multiply these two matrices, you will get this answer. Once if you are determining the DFT of x of n and h of n, you have to multiply these two matrices. Just you have to multiply these two values. Okay, these two. So 50 into 0, 0, right? So minus 3 you have to multiply it with minus j2. So 6j plus 6 into 2, 12. you have to multiply this j, j, what is the value of j? The value of j is square root of minus 1. If it is j square means, so just you have to cancel this square, you will get minus 1, right? This is minus into minus plus, sorry, minus into plus minus, again for j square is minus, minus into minus plus, 6 to 12, right? You got this answer. So similarly you have to solve other two. Okay, so you will get these two answers. Okay, once if you are determining the value of y of k, you have to find out, you have to apply IDFT equation in order to find out y of n. So you have to find out the y of n using y of k using a IDFT method, inverse discrete Fourier transform. In order to determine IDFT using 1 by n, this is the equation you know very well. This is a complex conjugate of twiddle factor. This is y of 4. This is the output. This output you have to substitute here. This is twiddle factor. You have already determined this twiddle factor, just you have to take the complex conjugate. Wherever we have that minus j, we have to put plus j. If it is plus j, you have to change the value minus j. See here, it is the twiddle factor, the complex conjugate twiddle factor. See here, this is plus j, this is minus j. Here plus j, we have to change this one as minus j. This is plus j. See here, is it correct? Then you have to substitute this value here, then you have to multiply these two matrices, you will get this answer. Okay, where is that? You will get this answer. Thereafter please don't forget to divide by 4.1 by n, right? 4 6 right, 4 6 4 6 24, 4 3 minus 3, right? This is 4 6 are 24 minus 6. This is 4 3s are 12. So this is your answer. 6 3 minus 6 3 here. 6 minus 3 minus 6 3. This is your final answer, right? This is your convolution of x of n and h of n value. Hope you will get understand this problem. Okay, so I have already uploaded books, 3 books in the first video of DFT. Please check it out there. And also I have uploaded one notes, DFT notes. So just make use of those files. It may be helpful for your exam. Okay. Um, Thank you very much. Happy learning. We will see in the next video. Until then, take care and bye.